Okay, good afternoon to all the students. Um, our first unit, which is based on the steam boiler and steam turbine, is finished. All the topic covered, like what is the steam turbine, what is the steam boiler, what are the mountings, what are the accessories, and what are the different type of boiler which is use and what is the classification of the boiler. All that things we completed, and now from today onward we're going to start our second unit, that is the IC engine and gas turbine. Okay, so what is the IC engine? Means internal combustion engine. Okay, so combustion, why we call the internal combustion? Because the combustion is done inside a chamber. Okay, that's why we call it internal combustion. Okay, the combustion is done inside the engine. Okay, so okay, students, let's start. So the first is internal combustion engine, means introduction about the internal combustion engine. So, like you see here, the important component is shown. The important component is shown here. This animated diagram. Okay. So here, this one, this one is our flywheel. We call it flywheel. Okay. And this moving part up and down, this is we call the piston. Okay, so this is we call piston. And the combination of this piston and here, this is the cylinder. Inside the cylinder, piston can move. Okay, so here red and blue. You can see here red valve and blue valve. Okay, one is inlet valve and one is outlet valve. Okay, so it work like it through the inlet valve, the air and fuel mixture inside the cylinder, and it combines by the spark and then expand and then compress again, and at least this outlet valve is open, and the uh, unnecessary or exhaust gases exhaust from the exhaust valve via outlet valve. Okay, this is your spark plug here. So 1, 2, 3, 4. So we can say that this is 4-cylinder IC engine. Okay, one flywheel is there and 4 piston and cylinder is there. Okay, this one is called the crankshaft. So we can discuss what is the component, different component of IC engine, and how we can use, and what is the purpose of this purpose of different component, and what is the different use of different component IC engine. So this is animated part, animated diagram. Now engine. So first we describe the engine. Okay. So an engine device transforming one form of energy to another form of the energy. one form of energy to another form of energy. Okay. Okay. So what is heat engine? First we define the engine. What can engine do? Engine can do change the one form of energy to another form of energy. Recording in progress. One form of energy to another form of energy. Okay, so what is the heat engine? A heat engine is a device which transforms chemical energy. See, which transform chemical energy of a fuel into thermal energy, and its thermal energy is again converted to the mechanical energy. Okay, so heat engine is a device. There is three conversion is there. Okay, so first conversion is transform the chemical energy of the fuel into the thermal energy, and that thermal energy converted to the mechanical energy as a useful work. Okay, like IC engine, we can say that this is a heat engine. Okay, because the fuel we can using like petrol, diesel. Okay, and through the chemical energy, because fuel, what is diesel and petrol, we can say that this is the type of chemical, and the chemical energy we can burn and generate the heat, and this heat is converted to the mechanical energy. Okay, so now IC engine. What is the IC engine? See, the internal combustion engine, also known as a IC engine, is an engine in which the combustion of fuel and oxidizer, typically maybe air. Oxidizer is nothing but medium which is add the oxygen, because oxygen is help here to burn the fuel. Without oxygen, fire can't be generated. Okay, so oxidizer, what is that? Air is used for the oxidizer. Okay, so occurs inside a confined space called a combustion chamber. Okay, the ethiopic reaction create gases at the high temperature and pressure, which are permitted to the expand that combined chamber thrust operated by this expanding gas device. Okay, thrust produced by the expanding gas drive the engine create useful work. Okay, whatever the thrust is created after burning of the fuel, that thrust is utilized as a useful work, like rotating the wheel of rattle.
Sir, what is meaning of thrust?
Okay, so these are the IC engine terminology. Piston cylinder. So this is your piston, and inside this is your cylinder. So this is piston cylinder assembly. It is the assembly for main plucking the work fluid. The assembly is characterized by a piston moving inside the combined cylinder. Like this, this is your piston and this one is your cylinder. Okay, inlet valve, this is your inlet valve. Okay, see here, this is your inlet valve, the valve through which air and fuel mixture in case of SI engine, okay, or air in case of CI engine. Okay, so SI engine is spark ignition and CI means compression ignition engine. Okay, so we also say that the SI engine means petrol engine and CI engine means diesel engine. Okay, so in the petrol engine, what happened? Air and fuel mixture
enter, and in the diesel engine only air is enter through the inlet valve. Okay, introducing inside the cylinder. Okay, exhaust valve, this is the exhaust valve. Okay, the valve through which the product of combustion leave the cylinder. Okay, from here enter and here from out. Okay, crank mechanism, this is your crank mechanism here. Okay, mechanism to convert the reciprocating piston motion to rotatory motion. So here piston is up and down, which is called the reciprocating motion, and this reciprocating engine is converted through this crank mechanism in a rotatory motion. Okay, bore, diameter of the cylinder. So here the diameter, internal diameter of the cylinder called the bore. Top dead center, it is called the TDC. Piston, position of the piston where cylinder volume is minimum. See, maximum. This is our top dead center. Means the highest position or highest peak of the piston inside the cylinder, that is called the top dead center. Okay. Bottom dead center, position of piston where cylinder is have maximum. So this is the minimum position of the piston inside the cylinder, that is called the bottom dead center. Okay, stroke, what is the stroke? It is the maximum distance that the piston move in one direction, its distance between BDC to TDC. Okay, so this is your stroke. Means one stroke means up and down, one up and down of a piston, that is called the stroke. Now clearance value denoted by the VC, minimum cylinder value where piston is at the TDC. Okay, so आपका जो piston है which is stand here, so whatever the volume left, that is we call the clearance volume. Okay, displacement volume BD. Okay, volume swept out by the piston, volume swept out by the piston at its movement from TD to BDC. ओके, तो मतलब ये आपका बॉटम डेड सेंटर टू टॉप डेड सेंटर के बीच में जितना भी वैल्यूम है, विच इज कॉल्ड आवर डिस्प्लेसमेंट वैल्यूम. ओके, कंप्रेशन रेशियो रिप्रेजेंटेड बाय आरबी, रेशियो ऑफ वैल्यूम एट टीडीसी एंड वैल्यूम एट वीडीसी. ओके, सो वी कैन से दैट इट इज द रेशियो, compression ratio is the ratio maximum volume to the minimum volume. Maximum volume to the minimum volume. Okay, so for this so student, for this I will share a short video for the working of IC engine, so you can better understand for the what is the working of IC engine and how IC engine work. Okay, just 1 minute.
An internal combustion engine is a heat engine in which the combustion of a fuel occurs with an oxidizer, usually air, in a combustion chamber that is an integral part of the working fluid flow circuit. In an internal combustion engine, the expansion of the high-temperature and high-pressure gases produced by combustion applies direct force to some component of the engine. The force is applied typically to pistons, turbine blades, rotor, or a nozzle. This force moves the component over a distance, transforming chemical energy into useful mechanical energy. Internal combustion engines are the most broadly applied and widely used power-generating devices currently in existence. Examples include gasoline engines, diesel engines, gas turbine engines, and rocket propulsion systems. Internal combustion engines can be described in terms of a series of thermodynamic events. In the continuous combustion engine, the thermodynamic events occur simultaneously as the oxidizer and fuel and the products of combustion flow steadily through the engine. In the intermittent combustion engine, by contrast, the events occur in succession and are repeated for each full cycle. Components of an internal combustion engine. Number 1. Exhaust camshaft. Number 2. Exhaust valve bucket. Number 3. Spark plug. Number 4. Intake valve bucket. Number 5. Intake camshaft. Number 6. Exhaust valve. Number 7. Intake valve. Number 8. Cylinder head. Number 9. Piston. Number 10. Piston pin. Number 11. Connecting rod. Number 12. Engine block. Number 13. Crankshaft. While TDC stands for top dead center, and BDC, bottom dead center. There are two kinds of internal combustion engines currently in production: the spark ignition gasoline engine and the compression ignition diesel engine. Most of these are 4-stroke cycle engines, meaning 4 piston strokes are needed to complete the cycle. The cycle includes 4 distinct processes: intake, compression, combustion and power stroke, and exhaust. Spark ignition gasoline and compression ignition diesel engines differ in how they supply and ignite the fuel. In a spark ignition engine, the fuel is mixed with air and then inducted into the cylinder during the intake process. After the piston compresses the fuel-air mixture, the spark ignites it, causing combustion. The expansion of the combustion gases pushes the piston during the power stroke. In a diesel engine, only air is inducted into the engine and then compressed. Diesel engines then spray the fuel into the hot compressed air at a suitable, measured rate, causing it to ignite. An internal combustion engine consists of 4 strokes. Number 1. Intake. Number 2. Compression. Number 3. Power stroke. Number 4. Exhaust. At the beginning of the intake stroke, the piston is close to TDC. The intake valve is opened, the piston starts to move towards the BDC air, or air-fuel mixture, is drawn into the cylinder. This stroke is called intake because fresh air mixture is taken into the engine. The intake stroke ends when the piston is at the BDC. During the intake stroke, the engine consumes energy. The crankshaft is rotating due to the inertia of the components. Stroke 2. Compression. The compression stroke starts with the piston at BDC, after the intake stroke is finished. During the compression stroke, both valves, intake and exhaust, are closed, and the piston moves towards TDC with both valves closed. The air mixture is compressed, reaching maximum pressure when the piston is close to TDC before the piston reaches the TDC but very close to it. During the compression stroke, for gasoline engine, the spark is generated. For diesel engines, fuel is injected during the compression stroke. The engine consumes energy. The crankshaft is rotating due to the inertia of the components, more than the intake stroke. Stroke 3. Power stroke. The power stroke starts with the piston at TDC. Both valves, intake and exhaust, are still closed. The air-fuel mixture combustion started at the end of the compression stroke, which causes a significant increase of pressure inside the cylinder. The pressure inside the cylinder pushes the piston down towards the BDC. Only during the power stroke the engine produces energy. Stroke 4. Exhaust stroke. The exhaust stroke starts with the piston at the BDC, after the power stroke finished. During this stroke, the exhaust valve is open. The movement of the piston from the BDC towards the TDC pushes most of the exhaust gases out of the cylinder, into the exhaust pipes. During the exhaust stroke, the engine consumes energy. The crankshaft is rotating due to the inertia of the components. As you can see, in order to have a complete combustion engine cycle, the piston has to perform 4 strokes. This means that one engine cycle takes 2 complete rotations of the crankshaft, 720 degrees. The only stroke which produces torque energy is the power stroke. All the others are consuming energy.
Students, now you can observe and understand how this IC engine is work. Okay, so for the IC engine, there is 2 type of IC engine. One is 4-stroke and other is 2-stroke. Okay. So whatever the different parts we can observe here, we can see here. Okay, piston cylinder assembly. This is piston and cylinder. Inlet valve, exhaust valve, crank mechanism, bore, top dead center, bottom dead center. So these are the terminology, and this is very much important for your exam perspective. Okay, so when in the examination ask about write the IC engine terminology or IC engine different component, so you can write the same things in the examination with a suitable diagram. Okay. Now, engine classification, how we can classify the engine. Engine design, working cylinder, fuel, cylinder arrangement, cam soft location and number, ignition system, combustion chamber design and application. Okay, so these are the category by which we can classify engines. Okay, so first is engine design. Okay, which type of design we can adopt for an engine? On the basis of that, we can describe or classify the engine. Okay, so we can see one by one on the different category how we can classify the engine. Okay, so on the basis of engine design, okay, reciprocating piston. So here reciprocating piston means piston motion is up and down like this, up and down like this. So on the basis of this reciprocating, we can divide 4-stroke and 2-stroke cycle. Okay, so mostly what happened, 2-stroke currently not used in automobile applications. Okay, and 4-stroke. Second is rotatory like this, rotatory piston and cylinder. Okay, so the piston is this and which is rotated inside and the motion is completed. Okay, the rotatory is like this and reciprocating is like this, which is most utilized engine in the current time. Okay, on the basis of working cycle. Okay, so engine working on the octo cycle, that is SI engine. So SI engine or petrol engine is work in the Octo cycle. So we can say that the Octo cycle engine is there, that is the petrol engine. Okay, engine working on the diesel cycle, CI engine. Okay, so diesel cycle is used for the CI engine, which is nothing but a diesel engine. Okay, so see the difference between this is your Octo cycle and this is your diesel cycle. Okay, so you can see the difference. This is in the diesel engine, this is our power stroke, and this is adiabatic compression is there, adiabatic compression is there, and this is the exhaust stroke. So in the diesel cycle, you can see the length A and D is more than here 3 to 2, which is in the Octo cycle. Okay, so but here we can see we can get fuel injection and compression. So whatever the time duration between the fuel injection, the same time is taken for the exhaust. The same time is utilized as a exhaust. Okay, so on the basis of working cycle, we can divide the engine into two, working on the Octo cycle and working on the diesel cycle. Okay, on the basis of fuel, okay, on the basis of fuel, we can divide the engine like a gasoline, petrol engine, okay, compression natural gases, CNG, compressed natural gas, CNG engine. Okay, so in current time, most of the car converted to the CNG because it is cheaper than using the petrol or diesel. Okay, so most of the go under this CNG engine, compressed natural gas, diesel, light diesel oil, or high speed diesel, like this. Liquid petroleum gas, LPG engine also available. Okay, liquefied natural gas, LNG. Okay, liquefied natural gas and liquefied petroleum gas, LPG and LNG. Okay, maybe these short form is asked in your examination or MCQ. Okay, what is the CNG, what is the LPG, what is the LNG? Okay, so you have to memorize that. Hydrogen engine is based on the hydrogen energy. Dual engine, so dual engine is nothing but it is can operate by two fuel. Okay, like a engine which is operated by the battery as well as petrol or diesel. Okay, multi-fuel engine, so we can use different fuel, more than two fuel we can utilize in a same engine. On the basis of cylinder arrangement, inline 3, 4, 5, 6 cylinder configuration. Okay, 3 to 6 a cylinder combination we call inline cylinder arrangement. V type. Okay, more than 6 we can utilize this. Okay, 6 to 10 cylinder we can use like a V type. Okay, see here, this is V type, this is inline type. Okay, radial, what is the mean of radial? So you can see this is the radial type. Okay, horizontal oppose, like this. Okay, so this is your horizontal oppose. What happened? If one cylinder, one side is compressed, then one side is expand, one side express compress and one side express, like this, horizontal or vertical. So next, on the basis of camshaft location, so where the camshaft is located, so on the basis of camshaft location we can divide into overhead cam, OHC, overhead cam, cam located in cylinder head. SOHC, one cam for the both intake and exhaust valve. See here. DOHC, separate intake and exhaust cam is available. And further is purse rod cam located in engine block like this. Single overheaded cam, and this is cam located inside the block. Now on the basis of ignition system, okay, so basis of ignition system, how spark can take place. Okay, so method for ignition, air and fuel mixture. Okay, spark ignition, SI engine. In the SI engine, gasoline, LNG, CNG and alternative fuel we can use in the spark ignition, that is the gasoline, LNG, CNG and alternative fuel. Okay, so in the spark ignition we need a spark plug to ignite the fuel. Compression ignition, CI engine, and in this category only diesel engine is available. Okay, now on the basis of combustion chamber design, okay, so bed design and hemispiral design. So in the bed design, intake and exhaust valve set in a plan, spark plug located above and below of the valve plan. Okay, hemisphere. Now what is the hemisphere? So valve set in two planes, spark plug located between two valves, more efficient in comparison to this, and higher output, means we can get the more efficiency or more output in the comparison to the this type of combustion chamber. Okay, now on the basis of applications. So on the basis of application in the automobile sector, so that is car, truck, bus, on the highway vehicles. Okay, locomotive is used for the train, light aircraft, marine, the engine which is used in the ships, power generation means portable and fixed electricity generator is here, agriculture like your tractor and pump set, earth moving device, house use. Okay, so these are the different type of application for which different type of IC engine is used. Okay, so now here difference between EC and IC. Okay, so what is the difference? You can see combustion. What is the difference between combustion? Okay, the main difference is where the combustion take place. In IC engine, fuel combustion take place inside the chamber, where in the EC engine it take place outside the engine cylinder. Okay. Okay, what is the EC? External combustion engine, and IC is internal combustion engine. Okay, so first difference is at its name, like its name, internal combustion and external combustion. Okay, the temperature and pressure in an IC engine is much higher than those of EC engine. Because what is the reason behind that? In the IC engine, what happened? Whatever the heat is generated, that is inside a chamber. Okay, so the heat loss is minimum in comparison to EC engine. Okay, next, in IC engine, the position of piston is differently connected to the connecting rod, where in the EC engine they are in a stuffing box. Efficiency is higher for IC engine. Okay, boiler are required for EC engine to store the water, which is the converted to the steam, but IC engine required only a much smaller tank to store the fuel. EC engine, unlike IC engine, can't be started or stopped quickly because it takes time to initiate the boiling of the water and generate